Now we have already discussed how to solve the system of linear equations using the inverse method. So now in this question, what is new? We are going to solve the linear equations with three variables x, y, z. In the last video, we have discussed the variables in the equations with two variables. Now x, y, z, three variables equations are there. So we are going to solve this equation using the inverse method. So how to solve this? How to take out the value of x, y, z using inverse method? We are using A inverse. So we know that this is the equation. Write it like this: 2 minus 3 5, 2 minus 3 5, and 3 2 minus 4, 3 2 minus 4, and the third equation is 1x 1y minus 2z, so 1 1 minus 2. So first A will be written according to the coefficients of x, y, and z here. In the second column, write x, y, z, and on the right side you have to write whatever values are on the right side: 11 minus 5 and 3, 11 minus 5 and 3. This is the this way we have to present the value. Ax equals to b. A is what? The coefficients of x, y, z. What is x? X is x, y, z, and b is what? Whatever is on the right side. Suppose any number is missing here. Suppose the equation would have been only this much: x plus y equals to minus 3. So z was missing, so we have to write at this place 0 because z is not here. So that means the coefficient of z will be taken as 0. In this case, it would be 0. So you have to write the 0 value there. Clear? So first step, we have to solve the determinant of A. So determinant of A is equals to this we are taking the first row, expand along the first row, and we have discussed in the previous video, we can expand along any of the rows. Expanding along row 1, that's 2 3 and 5, 2 3 and 5. We are getting determinant equals to minus 1, and we can see that this is not equal to 0, so the value of A inverse exists. If it would have been 0, then A inverse may or may not exist. This we have discussed in the previous video. So A inverse exists and it has unique solution. What is unique solution? Means x, y and z has only one value. One value of x, one value of y, one value of z. So this we have taken out. Now next step, we know that the formula is x equals to A inverse B. So how to take out A inverse? We know how to take out inverse. In the previous videos we have discussed how to take out the value of A inverse. For A inverse, the formula is this much: 1 upon determinant of A into adjoint of A. So first of all, we have to take out the value of adjoint A. Adjoint A is equals to the cofactors, transpose of the cofactors. So take out the cofactors of these values and transpose it, we get this adjoint A. I'm not explaining this again because we have discussed thrice in the previous video. So adjoint of A is in transpose of the cofactors of A. This is the adjoint of A. Now adjoint of A is divided by what? Determinant of A. This we have taken out minus 1. So divided by minus 1. This is the A inverse. So put this value of A inverse here. So put this value of A inverse here. So formula says x is equals to A inverse B. A inverse we have taken out. B is what? B is what? B is this much. So multiply these values. How to multiply? How to multiply? Row into the column. So 0 into 11 is 0. Minus 1 into minus 5 is plus 5, and 2, 3, minus 6. Clear? So we are getting x is equals so we are getting the value 1. Clear? Check the signs also. And same way, second row is multiplied with this column only. We are getting this, and the third row is multiplied by this column, we are getting this. Now compare this xyz with this value. X will be equals to 1, y equals to 2, z equals to 3. So this is the answer.